Hello, ladies and gentlemen. This is Miss Skokin. We are in Chapter 6, continuing our study of random variables. For today, we've got two learning targets. The first one is calculate and interpret the standard deviation of a discrete random variable. The second one is use the probability distribution of a continuous random variable with either a uniform or a normal distribution to calculate the probability of an event. Suppose you got a new job, and each day your boss, Miss Skokin, draws a slip of paper from a bag to determine your wage for that day. Let the random variable X represent the daily wage in dollars per hour. Now, if we were in class together, I would go around the room and I would allow you to select a slip of paper out of the bag so that you could determine your wage for the day. The slips of paper would have on them $1, $5, $7, $10, $15, or $25 for your daily wage. Another way that you can randomly get a wage generated is by using random.org/lists. So assuming that we went around the room and everyone selected from the bag the wage for the day that they were going to be earning, we would be able to fill out this probability distribution table. Now, remember that we've talked about, since our class is on the smaller side, we have often used a fictitious class of 30 students. So we're going to do that again. And we're going to say that out of our 30 students in the class, 3 out of the 30 got $1 per hour per day, and $5 per hour for the wage for the day was pulled from the bag by 6 out of the 30 students. For $7, it was 7. For $10, it was 10. For $15, it was 3. And for $25 per hour, it was only 1 student out of the 30. Now, the next thing that we want to do under number 2 is to calculate and interpret the expected value of X, which, remember, that means the mean of the probability distribution. When we do that, we want to definitely show all of our work. And you may remember from the previous lesson that in order for us to find the mean of the probability distribution, we're going to multiply each outcome by the probability of that outcome, creating a weighted average. And when we do this, with this particular probability distribution, we end up with 8.40, and then we need to interpret this value. Our interpretation is, if we draw many wage slips out of the bag, the average wage is about $8.40 per hour. And just a reminder of our formal definition of the mean or expected value of a probability distribution is the sum of all of the products of the possible outcomes times the probability for that particular outcome. Number 3 says, recall from Chapter 1 that standard deviation tells us the typical distance from the mean. Complete the table to calculate the standard deviation for the probability distribution. Now I'm just going to write down in the margin the formal definition or formula for the standard deviation of a probability distribution. And that is the sum of the squared differences between each individual value and the mean times the probability for that particular probability table outcome. So we're going to start out by filling in the table. In the value column, it's going to be the specific individual possible outcomes. The distance from the mean is going to be mu, or the mean, minus each of the individual values. The distance from the mean squared is the distance from the mean squared. And the last column is going to be the previous column times the probability for that specific outcome. So we start with 1 minus 8.40, and we end up with negative 7.40. We square that number, and of course no longer have a negative number, but have a positive number. We multiply that by the probability of the outcome of 1 for the random variable, and that gives us the weighted contribution to the variance. Next, pause the video and fill out the remainder of the table through the line for $25 per hour. When you're done, turn the video back on. Next, we're going to add up all of the numbers in the final column on the right-hand side, and when we add them all up, we end up with 22.64. Now, this is what we call the variance. And in order to get the standard deviation, we take the square root of the variance. Under number 4, we need to interpret the standard deviation. And if you remember, we were using some specific language for the standard deviation of a probability distribution, specifically referring to how much each individual value typically varies from the mean. Under number 5, it says Ms. Skokin decides she would rather assign wages so that employees could get any amount from $10 to $20 and all are equally likely. That's code for equal probabilities, which should indicate to you what type of a distribution that means. And the next sentence says, draw a graph to represent this probability distribution. So you may have guessed by now that that's going to be a uniform distribution, which means the same probability for all possible outcomes. So the uniform distribution generally is going to have the shape of a rectangle, and the smallest value that's possible based on what this part of the problem says is $10, and the largest amount possible is $20. All are equally likely, and we know 20 minus 10 is 10. The area under the curve has to be 1, so that means that the height of this rectangle is 1 over 10. Question number 6 asks us, what is the probability that an employee makes between $12 and $12.50? In our distribution, and this may not be exact, but we can shade that area in and mark it, so 12 and 12.50. And it is also a rectangle, so we know that in order to find the area under the curve, which is the same as the probability, we're going to multiply length times width. And that gives us an area or a probability of 0.05 or 5%. Let's take a look now at the box of important information on the next page. Our first learning target had to do with finding the standard deviation of a discrete probability distribution. And here's the formal definition where we take the square root of the variance, which is the sum of the products of the differences between each individual outcome and the mean of the probability distribution, the square of that times the probability for that specific outcome. Our second learning target was all about probability for continuous random variables, which is something that you will get some practice on in the check your understanding questions. And we know that finding the probability is what we do is we basically find the area under the curve. When we have a uniform distribution, which is a rectangle, then we're just going to multiply length times width. When we've got a normal distribution, which remember is defined by the mean and the standard deviation of the normal curve, then what we're going to do is we're going to find the z-score. We're going to sketch and shade, find the z-score, and then find the appropriate probability either using table A or using normal CDF. Now that brings us to the check your understanding questions. And you will have an opportunity again to work on the refresh your memory on normal probabilities using the z-score, using table A, using normal CDF. So what I recommend you do now is when you stop the video, work on the check your understanding and then look at the posted notes so that you can check your work against those posted answers. And I will see you back in class.